factor each polynomial expression completely. So we've seen some different techniques for factoring polynomials. Now let's kind of bring some of those ideas together, and here's maybe a roadmap, some ways to think of it. So first thing we always want to look for is a GCF, and that should always be our first step when factoring. Then we look at the number of terms. We say to ourselves, okay, well, one of the techniques we learned about was if there were 4 terms. Alright, so if we have 4 terms, we tend to think grouping. Alright, and then we saw, what if there were 3 terms? And so if there are 3 terms, well, then we have several different techniques. We can, if the lead coefficient is 1, we have a certain technique. So A equals 1. We did that inspection technique. If A was something other than 1, then we use the AC method. And we also want to be on the lookout for the perfect square trinomial pattern. And also, if we have 2 terms, we want to be on the lookout for the difference of squares. So let's kind of keep that in mind, and let's go through a few examples. Alright, so here we have 18a squared minus 32. Our first step tells us to look for a common factor. Let's see, 18 and 32, their common factor is 2. So I can first factor out the 2, and so let's see, I'd have 2 times 9a squared minus 16. So I've taken out the common factor. Now I look at that remaining binomial, and I see that they are perfect squares of 3a and 4 respectively. And so then I can factor further. Now don't forget the 2. Let's bring that 2 down. But I now have a difference of squares in the 9a squared minus 16, and so I can factor that as 3a minus 4 by 3a plus 4. Alright, exercise B. 10x squared minus 30x plus 5xy minus 15y. First thing I see is a common factor. It looks like I can factor 5 out of each of the terms. So let's factor out that 5. So I have 2x squared, let's see, minus 6x plus xy minus 3y. Now I see 4 terms. I'm going to try grouping. So I've got a 2x squared minus 6x in my first group, and I have a xy minus 3y in my second group. Alright, from my first group, I can factor 2x. So I'd have 2x by x minus 3. From my second group, it looks like I can factor out y, and so I'd have a y by x minus 3. And I now have the common binomial factor of x minus 3. So I can rewrite this as 5 by x minus 3 by 2x plus y. And that is the completely factored form. And a third example, we have 24a cubed plus 10a squared minus 25a. Alright, so any common factors? Looks like all I can factor out is the a. Alright, so let's factor out the a. So I'd have a by 24a cubed, a squared, plus 10a, I wrote an x, sorry about that, minus 25. All right, so now we see three terms. Think of our trinomial methods. This is not a perfect square trinomial because the 24 is not a perfect square. So we go to the AC method. All right, so let's see, we have A equal to 24, B equal to 10, and C equal to negative 25. So then A times C, let's see, A times C, 24 times 25 is 600, negative 600. All right, so we've got to find factors of 600 that add to 10. Well, negative 600. All right, so this is going to take a while. Let's see, we have 1 in 600. Let's say negative 1 in 600. Negative 2 and 300. Negative 3 and 200. Negative 4 and 150. Negative 5 and 120. Negative 6 and 100. Negative 6 and 100. 7 doesn't work. 8 and 75. 9 doesn't work. 10 and 60. 12 and 50. 13 won't work. 14 won't work. 15. Negative 15 and 40. 16 won't work. 17, 18, 19, and 20. Negative 20 and 30, and I think that's all of them. Oh no, 25. 25 and 24. So I think that's all the pairs of numbers that multiply to 600. Now we have to kind of go through them and find the pair that also adds to 10, and I'm not going to do it for every single one, but I noticed that negative 20 plus 30 is 10. So that's the pair that I need. So then I have A and 24A square. Let's see, minus 20A plus 30A minus 25. And now I use grouping. Alright, and by grouping, let's see, my first group, I have a common factor of 4a, so I have 4a by 6a minus 5. My second group, I can factor out of 5 by 6a minus 5. I see I have a common binomial factor of 6a minus 5. So I can write this as a by 6a minus 5 by 4a plus 5. And that is the completely factored form of the original polynomial.